Sorry for the cluttered picture, but I was trying to implement all the different ways you could define vectors and how to add them and subtract them and so forth into one problem, so I don't have to do multiple problems to explain this topic. So if you got anything harder than this, I don't think there'll be anything harder than this, to be honest. But this should be the most difficult thing in terms of defining vectors and adding and subtracting them. So what we're going to start off with is define the vector a, since it's the simplest thing to do. So if you understand this whole video, you should be fine with vectors, at least for adding and subtracting them. So we could define a. So I'm going to define the axes as x and y. So we're going to just look at the x and y axes. So this will be y, this will be x. And then we could define this blue vector as a. And we know this angle is 30 degrees. So we could define this vector a by using some trig. So it'll be a cosine theta, or 30, and then plus a sine of 30 in the positive direction, since we define x to be positive here and y to be positive there. So now that we have that, so we can just plug in what a is, which is defined to be 4 feet. So it would be 4 cosine of 30 I plus 4 sine of 30. So then the cosine of 30 is square root 3 over 2, which is just 2 square root of 3. And then this should just be 2j hat. We have the vector a defined by using trigonometry. And now the only way is, since the b vector lies on this green dashed line, and it's somewhere in 3D space, we have to use unit vectors to define the vector b. All we're given is that the magnitude of b is 8 feet. So if we want to add them together, we got to find the components of that vector. So what's nice about this problem is that we were given these two vectors r1 and r2, which point to this line and lie on this on this green dashed line. So we could use this to find a unit vector and then multiply that unit vector by the magnitude of b to find the vector b. So what we're going to do, we're going to define r1 to be this. Since we're given all the components, we could just simply use that to use vector notation. So we define x to be positive in this direction, so any x value in this direction has to be negative. So for r1, the negative x direction is this value, 1 foot, so it'll be negative 1i, positive 3j, and then plus 5k. Alright, and then r2, that's simply the same thing, so negative 2i plus 5j, and then plus 7k. So now that we have these vectors, we could define a unit vector which points in this direction. So I'm going to say that is the unit vector. So we could define u to be as this. So we could say u equals r2 minus r1 divided by the magnitude of r2 minus r1. So we're going to do that subtraction. So r2 minus r1, so negative 2 minus 1, that's negative 3i, plus 5 minus 3, which is plus 2j, 7 minus 5, that is plus 2k. Now we could find the magnitude of these, so that's simply the square root, as we learned before, the square root of 3 squared plus 2 squared plus 2 squared equals that. So what we can simplify this to is this is 9, so that's 4 plus 4, that's 8, 8 plus 9 is 17. So we can rewrite this as this plus, this is I, plus 2 square root of 17 plus 2 over the square root of 17k. So now this is a unit vector that points in the direction of b. So now we could find the vector b by simply writing this. So b is that. So b we said was 8 feet, so we multiply everything by 8. So it would be negative 24 over 17i plus 16 over the square root of 17j plus 16 over the square root of 17k. So now that we have b defined and we have a defined, so a is equal to 2 square root of 3i plus 2j, we could finally add and subtract these vectors. So what do we want to find? We will find a minus b, or a plus b. Do that one first. So a plus b is very simple. So all you have to do is do 2 square root of 3 minus 24 over the square root of 17i plus 2 plus 16 over the square root of 17j plus 16 over the square root of 17 plus 0 k hat. So after plugging into my calculator, these are the values I get. Now to find a minus b, we simply repeat the whole process again. So a minus b, so it'd be 2 square root of 3 plus 24 square root of 17 I, and then we're going to do plus, and then as an a, so it'd be 2 minus 16 over square root of 17, that would be j, and then plus k, so it'll be minus 16 over square root of 17 k. So after plugging into my calculator, those are the values I get for a minus b. So we get positive I minus j minus k. So we get positive I. So we're doing a minus b. Ooh, this is kind of difficult to visualize. So a minus b, ax is positive, a bx is negative. So we get a positive value when you subtract. Oh, we subtract them. So this is going in the x direction. So we flip it 180 degrees. So now both of these vectors are pointing in the positive x direction. So that's why we get a positive x value. And then negative y. Okay, so now b is now flipped going downward and to the back. So that's why we get negative values for j and k, which makes sense. So if you can't really visualize that, just give it some time and practice, and you'll start seeing why things seem to be correct, at least. And not necessarily computational correct, but at least in terms of the geometry. It should be, you should have some intuitive sense of why it's correct or incorrect. So that is the whole process of defining vectors and adding and subtracting vectors. This is probably the more complicated examples. So if you get this down, you pretty much solve a good amount of statics problems when we get to ideas of equilibrium and particle equilibrium and planar equilibrium and stuff like that. So that's it for this video. Hopefully you guys fully understand these concepts of vectors and adding and subtracting them. I hope you guys enjoyed it, and in the future video we'll start talking about talking about equilibrium, the idea of the Newton's laws and so forth. So that's it for now. Look forward to the next video.